all this. No coughing in class. And that'd be 1 over, and then you take your handy dandy calculator and you type those in. So that would be, I done lost it. There we go. So let me just go do this because it's a whole lot easier. Second function, enter. And second function, enter. I thought I had a combination in there somewhere. I guess I didn't. Okay. All right, so 59, math, combination, 5, enter. There's that VA number. And then you're going to multiply that by, and I'm just going to store that. Stove, like where you get bread, that's stove. Stove, I'm going to say alpha, and we'll call it F for first. F, where's F? There it is. And enter. And then I'm going to take, what's the other one? 35, combination, math, probability, there we go. What, 1? It should be 35. Oops. Enter. Dang old 35. And 35 times alpha, F, where's F? There we go. Equals, dang old 175 million. So my chances of winning the lottery is, y'all got to help me out. I've done lost it. There it is. 175,223,510. 175,223,510. All right, somebody do that on your calculator and give me the decimal to 10 digits. Take your calculator, Miss Joshi, and tell me what you come out with.
So what do I have to do?
Give me the decimal to 10 digits. What is it?
I don't know what to do.
Okay, take 1 divided by this number and hit equals somebody into.
5.7.
I'm sorry, what?
5.706996738 to -9.
Times 10 to the what?
-9.
-9. All right, now let's take this. Let's have some fun with it. I'm going to give y'all a class in Joel Brawley. He was a professor at Clemson, a teacher of mathematics, and he did this. He didn't do it the way I'm going to do it, but he did this one day. He was a teacher that loved to talk about gambling. And he would take up his whole lecture and talk about gambling. I don't think he was a gambler. I think he just thought it was interesting. So why was if some of y'all might not remember, Ms. Cowart, and some of you non-traditional students may remember, back about 12, 15 years ago, I don't know when it was, the lottery came to South Carolina. And oh my God, you thought the world was coming to an end. Why? Why South Carolina? I mean, other states had the lottery. We had video poker, which was crack cocaine and cigarettes of, the video poker. Video poker was the crack cocaine and the cigarettes of the gambling industry. Everybody's brothers, kids were outside playing in the parking lot while mom and dad were in there playing video poker. But we did not want the lottery. Why? Well, what are,
They consider that gambling.
Yeah, considered it gambling, but video poker wasn't. Why? Because we're South Carolina. And what is South Carolina next to Mississippi?
In the Bible Belt.
No, not Bible Belt, but we're ignorant. Right? We're always right beside Mississippi as far as what? SAT scores, right? which doesn't mean anything, I'm being facetious, but the whole point is, we're a bunch of dumb, ignorant, racist, backwoods hillbillies in South Carolina that we don't have sense enough to know when to buy tickets and when not to buy tickets. That's why they didn't want the lottery coming. But let's look at this. If I buy one ticket, let's say I'm playing Powerball. I buy one ticket. My odds, my probability of winning is, let's see, 5, 7, 0, 6, 9, 6, 7, 3, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. My odds of winning, my probability of winning is 0.000000005706, blah, blah, blah. You with me? Well, Bubba, who is the dumb southerner, he says, well, I'm going to show them lottery people. I'm going to buy 10 tickets. Okay? 10 tickets is basically going to take a what off of this? A what?
Is it a 0?
It's going to take a 0 off. So instead of 1, 2, 3, 4, 5, 6, 7, 8, you're going to have what? I'm going to stop it at 5706. I don't feel like writing all that. And then Bubba starts to think about that thing and he says, well, I'm going to buy 100 tickets.
How much are tickets?
Like $10 a ticket or $20 a ticket or something like that. No, $2 a ticket. $2. But it used to be $1, but now it's $2. They made the pot bigger or something. So he buys 100 tickets. Well, that takes off another 0. 1, 2, 3, 4, 5, 6, 7. So now it's 1, 2, 3, 4, 5, 6, 5, 7, 0, 6. He thinks about it and he says, you know what? It'd be better if I buy 1,000. Well, that's going to take off another 0. Basically, you get the point. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And then he says, I'll buy 10,000 tickets. Then he'll say, I'll buy what? 100,000 tickets. And then finally he says what? 1 million tickets, sorry. Okay, now, in today's society, we round everything money-wise to the what? To the 100th, right? Your gas, your cents that you buy stuff with, you know, Walmart, $3.97. It's not $3.96874. It's $3.97. We round everything to the 100th, right? So what is, if you round everything to the 100th, which that's what we do, what is your probability of winning the lottery? Whether you buy one ticket or whether you buy 1 million tickets. What is it? So who's the smartest cookie? The one that buys one ticket or the one that buys 1 million? The one that buys one. Because he's got the same probability as the guy that buys 1 million. The guy that buys 1 million is the DA. Think about it. You don't go out and buy 1 million lottery tickets because you think you're going to win the lottery. You go out and buy 1 lottery ticket or 10 lottery tickets and just have fun with it. But that's one of the reasons why they thought that everybody in South Carolina was going to go out and mortgage their house and sell their kids because they thought we were dumb enough to do this. So, and a lot of people don't even think about this when they're buying $200 or $300 worth of lottery tickets. I guarantee you somebody in your family or you know somebody that knows somebody that has at least bought $300 or $400 worth of lottery tickets. You might as well took that $250 and paid a bill with it, because your chances of winning are what? The same. Okay? So make sure you know how to do the lottery. Oh, we need to check, make sure we were right. There's our number right there. Let's check and see. So let's go back to our South Carolina lottery. There we go. And let's see what the odds are. Well, I lost it. Let me go back and find it. There we go. Odds. What did they get? 175, 223, 509? Or I don't know which one's which, but anyway, I'm gonna pull up mine. 175, 223, 510. 175, 223, 510. Look at there. 175, 223, 510. It's a miracle. Got the same number they did. Yes, sir.
Well, how often is the lottery like called?
It depends. Usually it's every, somebody help me out, every other day. It has a drawing, like at 11 o'clock at night.
Smartest person would,
Huh?
so it's a really smartest person wouldn't play, because if that's $2 every other day, then,
Yeah, and that's why some people just play it whenever it's like the $100 million or better. Because, you could, actually,
you could have profit if you want.
yeah, $20 every single time the lottery drew. You're talking about every other day, that would be, what, 15 days? You're talking about $300 a month. So that's really not too smart. Question, right, complaint. All right, now I want you to do, let's do the, what's the other one called? Mega Millions. I want you to do it, and if you can do it, then, and would do the one we just did, then, there you go. And the question will read, it'll say, the question is a test question, it'll say, where's Vanna? Okay, one of y'all's going to be Vanna today. Hit the magnifying thing. Magnify us on the left-hand side, plus, blow it up, there you go. Way to go, Vanna. Vanner, we'll call you Vanner. All right. On a Mega Millions play slip, select 5 different numbers from 1 to 75, and then you have the Mega Ball, which is 1 to 15. And the question will read, what is your chances of winning the lottery if you have numbers from 1 to 75 for the first 5 numbers, and then one number being 1 to 15. That's what the question will say, something like that. My first thing to you would be put a 1 in the numerator, because that's what, unless it specifies that you bought 20 tickets or 10 tickets, it's assuming that you're buying 1 ticket. All right, Remy, you could bring it down, hit the minus symbol until you see the drawing board and everything. Keep going. Keep going. There we go. All right, this one says, how many spaces were in the first 5 balls? And 1 to 75?
Yeah.
So it'd be 75. Combination of 5. And then the Powerball, or the ball by itself, is what? 15? And these are multiplied together. So you take your handy dandy calculator and you do the 75, because 15, combination of 1 is basically 15. But you take your handy dandy calculator and hit second function entry, there we go. And second function entry will give you 75, combination of 5, and that's a BA number. And then multiplied by, I don't know if I can do this or not, but I'll try it. Second function entry, no, it's not gonna let me do it.
No, you can just multiply and it'll give you the numbers.
Well, I was gonna try to do that, but it didn't, oh well, I'll just 15 and then 1. Thought it would. Okay, and then just take 15 times 172, 593, 90. It's gonna be a BA number. 258, 898, 50. 258, 898, 50. So let's go back to the odds. $258, $898, $50. There it is. It's a miracle, we got it right. You just got to know how to arrange your numbers. That's all there is to combination and permutation. Well, how do you do it if you don't have a calculator? Well, you pull up your handy dandy Excel spreadsheet. And you type in permute or combin. Okay? Let me show you. Okay, go away. I don't know why you're saying that. Just say equals combin. C-O-M-B-I-N. There it is right there. Not combina. I don't know what combina is, but combin, or whatever that is. And then parentheses, what was it, 15? No, it was 75, comma 5. So 75, comma 5, parentheses, enter. There's that number. And then combin, parentheses, the second one was 15, comma 1. And then you multiply those two guys. This times this. And that dango will give you the same number. 258, 898, 50. And that's how you use the Excel spreadsheet. Combin. Well, how do you use permute? Well, permutation is permute. Equals permute, parentheses, 15 or 75, comma 5, and of course you're going to get a bigger number because you're not dividing by that 5 factorial. When you divide by that 120 or that leftover factorial, you're dividing a bigger number by another number, and therefore the combination will always be smaller than the what? Than the permutation. Okay? So that's how you use it. Permute, P-E-R-M-U-T, and combin, C-O-M-B-I-N. And then parentheses, N, comma, R, close parentheses. All right, let's look at some of your problems now. Because basically, I've covered chapter 4, 4.6, because we're not doing 4.5. Let's see, study plan 4.6. Let me find one that I could fit this. Okay, here we go. A presidential candidate plans to begin her campaign by visiting the capitals in 3 of 40 states. Visiting the capitals of 3 of 40 states. What is the probability that she selects the route of 3 specific capitals? It is practical to list all of the different possibility routes in order to select the one that is best. Well, this is a combination. Why?
Because it's not an order.
Not in order. So it'd be 40, combination what? 3. I don't know you use 40. That's always the largest number. N is always your largest number. So 40, combination of 3. So pull out your Excel spreadsheet, and then we'll go right here and type in 40, combination 3. I got 9880. What'd y'all get? Huh? Good job. All right, where'd my question go? It just disappeared. Not that one. I hate it when it does this. There it is. What did I say, 90 what?
9880.
Okay, then I got a problem then. Oh, it said a fraction, okay. I said, what, is it practical to list all the possibilities? What is the probability that she selects the root of 3 specific capitals? So that would be 3 over, that's probably, Did they do a permutation? They must have done a permutation. I don't see any order. In order. There it is right there. Duh. Oh, we didn't see that. My bad. In order. Right there.
So everything we have to divide.
So that'd be a permutation. That's why it's 59,280.
So we, like whatever the answer is, we have to divide by 1.
Well, this one it says right here, what is the probability that she selects the root of 3 specific capitals? In other words, that's 1, yes. In this case, in the lottery, it's assuming that she's going to 1. The 59,280, I didn't see that order right there. I didn't see that. That's why. So you take your handy dandy and turn it back into, let's see, 40. Let's see, 40 and 3. There we go. 59,280. You got to read the questions on these. That gives you an example of what happens if you don't read it. And it says, is it practical to list all the different possible routes in order to select the one that is best? And in this case, I would say no. But that's just mine. So, because the permutation is very large, I would say this one. But I get those questions wrong, so I got it right. Because that number right there is so big, 59,280. Now, if it was like 6, it'd be different. Or 17, or 28, then it'd be different. But 59,000, that's too much.
So you have to
too
put
big.
a 1 up there because of what?
Huh?
Why did you have to put the 1?
Because she's going to go to one of the states. She's going to go to one of them. That's what it says in the problem. So, that's not one I would choose on the test. This is a homework question that comes to me very much. In other words, y'all send this one to me. And I think I've got 2 people that have already sent this one to me. One out of my online class and one here. So we'll do this one. A fan of country music, probably old country music, not now, plans to make a custom CD with 10 of her 28 favorite songs. How many different combinations of 10 songs are possible? No order. So this is what? Better be a combination because there's no order. So 28 what?
C.
28 C10. So 28 C10. All right, 28C10. Oh, yeah. That's pretty big. You're talking, there's, let's see, 110, there's 13 million arrangements of songs. Make sure I put that down right. 28 combination 10, yeah. That's 13 million different combinations. Now, you think it's practical to make a CD? No, that's too big. A CD of what? Well, read the question. It says, if I can find the question. It says, is it practical to make a different CD for each possible combination? Yeah, you're just going to walk around with 13 million CDs in your pocket. Because that's how many different combinations you have. So what do we have? 13 what? Million? I'm just going to type in 13, but it should be 13 million. There it is, 13 million. Was it 123, 110? And it says, no, it's not practical. And then because the combination is very what? Large? Unless you just want to carry around 13 million CDs. Reckon that's new country or retro country? No comment. That could be a test question. But that's not the test question I usually pick. There's a test question. And why do I give y'all this test question? Because I want you to have some points. It's real simple. How many different ways can the letters of attractive be arranged? Does it say meaningful words or does it say arranged? It says arranged. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it 10 digits or 10 letters? So that'd be what? 10 factorial, which is probably going to be a BA number. So somebody do 10 factorial, I'll do it to check y'all. Dang old 10, math, probability, 4, dang old 3,628,800. Is that what y'all got?
Yeah.
So there's 3 million, over 3 million different ways to arrange the words in attractive. I got 302,000. Did I do something wrong? Ten factorial. Did I not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, something's wrong. Because I did 10 factorial. It should be factorial. Oh, they're using the fundamental counting rule on this one. But there's 4 factorial. Okay, this is a rule. I don't know. We didn't go over this. There are 9 letters. Okay, there it is. Okay, I didn't. Let's go back. Let me go back. Go back to right here. Fundamental counting rule is right here. Oh, okay. That's when, yeah, that's the one I told you we didn't use. Right here. Number 4. So I don't use that one. But that's number 4. I don't use that one. Which is, it says n factorial over, and then you'd have to divide the 10 into, it says right here, it says if the 10 letters, blah, 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 are available and all 10 of them are to be selected without replacement, blah, blah, blah. You'd have to use 10 factorial, and then that would be 4, 2, and 2 because of the replacement. That's why I don't cover these. So on this one, you'd have to use that same logic. Where's my problem? Where'd it go? Right, I lost my problem. I guess it's time to quit, isn't it? 4.6. I don't know which question it was, but I think it was this one or the one before it. No,
Number 6.
we did that one. Grammar, 1, 2, it's gonna have to be done using, so that's 1, 2, 3, 4, 5, 6, 7, so it'd be 7 factorial. And then you would use fundamental counting rule right here.
So you do factorial and then you divide by them?
So that's 7 factorial would be up top. And then the next one would be the division of 7 factorial. So in this case, 3 3s and 3 2s, you'd have to count the ones that are identical. So in this case, grammar would be 2. There's 2 M's and there's 2 what? 2 R's and 2 A's. So you would have to take that into effect. So it'd be 2 factorial, 2 factorial, and 2 factorial on this one.
That would be multiplied?
Now in this case, you got, let's see, 9 letters with 3 E's and 3 T's. So there's your 3 E's and 3 T's. So in our case, it would be 1, 2, 3, 4, 5, 6, 7. 7 factorial over 2 factorial, 2 factorial, 2 factorial. That's what it should be. So 2 factorial, 2 factorial, 2 factorial is 8, right? And then 7 factorial on top. So y'all help me out. That'd be 7 factorial over 8. So let's see what I get. 7 factorial.
You won't have to do the 8 factorial.
630.
Hold on a second. 7 factorial. I'm checking to make sure because I haven't done these. 7 factorial divided by 8. Because 2 factorial times 2 factorial times 2 factorial is 8, right? Yeah. I got 630. That's how you do it. So on this one, y'all can tell I don't put these on the test very often.